So good afternoon, everyone, and thanks to the Transport Catapult for also inviting me along today to speak. As you heard, I'm a geographer by trade, so transport is relatively new to me, but data isn't. So I wanted to talk about mobility in the concept of a city. And when I started thinking about this, a city isn't really a computer, is it? But it does produce an awful lot of data. So if it's not a computer, then what is it? If you think back to how cities evolved, planners and scholars, since the age of time really, have been trying to understand how we make a city better for its citizens. How do we make a city be more productive? How do we release the potential of all those citizens? So ultimately, I wanted to bring back a little bit of history, a bit like Jason was talking about earlier. Now, I'm no technologist, but I started to think about the concept of a city not being a computer and thinking about how could I describe this? So I thought back to the late 90s and Garry Kasparov. I don't know whether you know, Garry Kasparov was a world chess champion. In 96 and 97, he played a computer called Deep Blue. And the significance of this is that Deep Blue won the second game, meaning that ultimately artificial intelligence was starting to catch up with human intelligence. But I then got to think, because if you had Deep Blue and Garry Kasparov in the same room and a fire broke out in that room, who would you put your money on to get out of that room safely? Not Deep Blue. So the point being that Deep Blue can only do one thing, play chess. There's nothing wrong with that. But if we think back to our smart city concept, and we think of all of that data, Nabil has just been talking about how we're collecting it, then ultimately, if we connect it all together, and we have lots of Deep Blues, Deep Blue is an IBM computer, by the way, then ultimately we could solve lots of different scenarios, and that's where we are today. He says, right, so if we think back to our citizens, I'm not going to go through the whole concept of a smart city. I'm no expert in that area, but I tried to think about in the concept of a smart city and impacting on citizens and how you make citizen life better, then what are the things that matter to a citizen? So energy is important to us, so is the environment, and those two are obviously quite closely linked within a city environment. The physical infrastructure, so buildings and things like that. Public realm. Public realm is a big thing for cities these days. How do we create areas where people can enjoy themselves? And then finally, and what we're here to talk about today, is mobility. How do we connect all of these things together? So that's what we're going to talk about ultimately. Again, looking back in time, a little bit further this time to Londinium. Londinium, created around 2,000 years ago, so London, just in case you needed that explanation. It was surrounded by a 2-mile wall. And within that 2-mile wall was quite a complex road network. And at its peak, Londinium was home to around 60,000 inhabitants. So as you can imagine, 60,000 inhabitants within that small area, at that peak, it became quite difficult, quite congested to get from one side of the city to the other. So evidence has been found relatively recently, or well, they thought this, but they have found evidence whilst they've been digging out for Crossrail, that they actually built a north circular road, the first north circular road. So actually, you kind of think about this, and I was trying to work out how they would have got to this, because they didn't have any data, did they? Maybe they did a very early form of an RSI, or maybe they just stood in the middle of the city and said, oh, this isn't working, how do we get around it quicker? So ultimately, fast forwarding to where we are now, there's been lots of talk in this festival and probably more insightful at other conferences as well, about how we solve congestion. Mass transit, and that's the original mass, not Mars. So basically lots of people on one thing, so public transport. Active modes, I'm a great advocate of active modes. I partly cycled here today. And shared vehicles, another way of resolving congestion. Autonomous vehicles have been covered in much greater detail than me. I've never been in one, so I'm quite envious of those that have. And then finally, that's my brother. I don't think that's me. He looks like me. This is the new mass, and how do we integrate those things, and what impact do they have on congestion? So that's the question I was posing myself. If we had all this data and we looked at those historical forms of solving congestion, what impact did they have? Well, historically, new forms of transport have been trying to have a positive impact on congestion, i.e. reduce it. So I tried to put them along this line, and you may agree or disagree with my placement of these. So obviously, active modes, they do have an impact on congestion. They can decrease it. Obviously, public transport does. Shared vehicles do. But autonomous vehicles, personal autonomous vehicles, do they really solve congestion? And mobility as a service. And I think unfairly, in this example, I've put mobility as a service on this side, because I think currently, the way mobility as a service stands, it doesn't necessarily help us with congestion. But in the future, I think it will, providing we do it correctly. So, as you know, I'm from O2, and we use our data in the transport sector, which I'll come on to in a minute. But this is my very simplistic view, as you've probably noticed by my northerly accent. I am simple. Essentially, I've got three areas of mass. So there's the first, understanding demand, how that changes over the day. Then we've got that integrated transport network, all the providers. I'm sure there's some of you here today. How do you all talk together and provide that service? And then you've got the user interface. But actually, a lot of the things that I've heard, read, and other conferences that I've been to have really concentrated on this element, the user interface part of mass. Whereas actually, I think a really important part of getting mass off the ground is understanding demand. Because if you don't understand how your citizens currently move around a city, then how do you provide them with a service that they're going to use? So that obviously neatly falls into my bag of being at O2. We do use mobile data. Some of you may have used it already. So everything that we do is actually, well, actually before I go on to that, everything that we do is using the mobile signal. It's not using GPS or anything like that. And the great thing about that is that it uses 2G, 3G, and 4G data. There was a question earlier, actually, about smartphones and how sort of the older generation don't have smartphones. Now, I don't have any exact statistics about this, but I am a geographer after all. But around 90% of the population have a mobile phone, and actually only 2/3 of them, it's predicted, have a smartphone. So that's potentially 15 million devices in this country that are not smartphones. So the great thing about mobile data is it picks up 2G and 3G as well as 4G data, so we can understand mobility. So what we do is, in this very data savvy and particularly data savvy press world, we anonymize everything that we do. So you can't actually tell it's me. We then aggregate. And when I say aggregation, I mean we aggregate to around groups of 10 in the population. So we really can't understand, we can't link it back to Rob Wilkinson, the person standing here today. What we do is we collect that data in real time, and that's pushed up through our network. So we probe the actual network towers. We then stick it in something that I believe people like to call the cloud. I'm yet to understand exactly what the cloud actually is. I think it's just where data is stored. But we also store it. So we pull it from the cloud and we store it historically. And that's really important, that I'll come on to in a minute, because historical habitual behaviour is very important when understanding demand. We also pull that historical behaviour and the real-time data and compare the two together. So if we take my habitual behaviour, so I live in Bicester and I work in London. And I do that journey around 15 times a month, so 3 times a week, thereabouts. Actually, I tested how habitual we are the other day. When I got on the train, I went and sat in a chair that somebody else always sits in. And when he got on, he was really confused and couldn't quite work out where he was going to sit. But anyway, that was a bit unfair, so the following day I didn't do it. But at Bicester, I get on the train with about 80 other people, and there are actually about 500 people on this particular service that I get in the morning. So there's lots of data there. So we're all travelling at the same speed at the same time, and we all get handed over across the network to the various cell towers along the way. Now, unfortunately, I'm not in our network team, but unfortunately for our network team, and as I'm sure unfortunately for you as an O2 or a Vodafone or an E, I think that's the other two providers, isn't it? Yeah. Ultimately, you don't have a signal all the time, particularly in a tunnel. So, but that's really good for us because you all lose and regain signal at the same time. So, what do we know about that person? So we know that I have travelled on that particular route. What do we know about when they get to London? Well, we can understand, and this is a very generic, sort of simplified diagram, but ultimately we can see which direction in London they travel on. We can also start to understand what type of connected transport they might take next. So, for example, of the 45 people travelling to the south of London or south of Marylebone, 90% of them go on the Underground. We also know that, if you click it, there we are. So how could this be used in real time and using the habitual behaviour? So habitually, we know that I make that journey. So on one particular day, if I don't make that journey or several people don't make that journey, what happens? Well, nothing really, because everybody else has made that journey and made those connections, so we can test that. But what if everybody on that train doesn't make a connection after the tunnel? And possibly any connection after that. So perhaps that's displaying some sort of congestion on the network. Now, you might say, so what? The train provider knows that. Well, yes, of course they do. But in our smart, connected world, actually, what's the impact of that? So, obviously, the line that I get on goes north to Birmingham and south to London. So what's the impact on all these other connected towns and cities above us? And what's the impact in London afterwards? And so if we think about how mobile phone data, because it's habitual and we have historical data, and we also can collect it in real time, if we combine the two things together, then we can start helping people understand better the impacts of various congestions and things like that, network planning, etc. So we talked about data. I like to call mobile data, and some of the data that Mobile talked about, is exhaust data. So it's data that's produced from something that it wasn't meant to be. So mobile phone data wasn't there so that geeks like me and my colleagues could delve into it. It was there to provide connectivity to you as customers. But ultimately, for citizens, if we do use that data properly, we can help them with their daily lives. They can make decisions in a much more productive fashion and ultimately improve or impact their productivity positively. And I was trying to round this up with the data oil analogy. And I think it's important that we keep the data clean. Oil. The data has to be maintained and secure, just like our mobile data. We cannot reveal the identity of individuals. And ultimately, we must keep maintaining that oil to make sure that it is still relevant as we go through. Thank you very much.